And this is a quiz by the OG of IT. I'm talking about myself for third person. IP networking, blankcast, anycast, multicast, unicast, and broadcast. Your first question is this. What type of virtual IP address is provided by a first hop redundancy protocol? FHRPs. That would be an example of an FHRP would be Hot Standby Router Protocol from Cisco, VRRP, an open standard, and Gateway Load Balancing Protocol. And in the CCNA blueprint, they ask you, describe the functions and benefits of an FHRP. So my question for you is, what type of virtual IP is provided by an FHRP? All right, Converge World, thanks for pointing out the laughing out loud at the Keethernet. I got that from somebody in Discord. They're talking about some protocol. I think it's Keethernet. All right, I'm going to toss that one out as not being a valid answer here. Okay, what type of virtual IP is provided by a first hop redundancy protocol? And 57 of you, which got the majority, said it is unicast. I would totally agree with that. And this is show standby. This is how you'd verify a hot standby router protocol on a router. It's implemented on layer 3 interfaces. The benefit is that we're providing a fault-tolerant default gateway that clients can use. And here it is. It's a virtual IP address, so your clients would point to this as a DHCP client as their default gateway, like 25.2.2.100, and they'd have 2 or more devices that support that address. So if one device fails, the clients will still have a default gateway. And I'm running version 2 just because it's like 3 commands to do it. And there is the virtual MAC address that's in use. So group 25, this right here is in hexadecimal. And that represents 25 in decimal, represents 19 in hexadecimal. You don't need to memorize that part, but this is the MAC address for it. It is a unicast address. This guy is right here. And that was the question that I was asking. So thank you everybody who took a stab at that. And if you're just learning about that, that's great too. I'm super glad that you're here. Now, there is a little trick to this platform, and that is this. Every question you get correct, you get points for. And if you answer it more quickly before the time runs out, the more points you get. So an answer like boom right up that will get you more points, and an answer boom like that will also get you no points if you fail it. So in the certification exam, you want to read the question and think, oh, I know what this is. Make sure you're looking at all the answers and then ruling out the ones that don't fit and then going for it. I probably got at least 15 direct messages, emails, comments this week about people who have passed in the last week. Congratulations. Way to go. I'm so proud of you. They all said, Keith, thank you very much for your insights and help on getting this done. And my answer to that is, you did it. You did this. You took the resources that you had, and I have provided some along the way perhaps, and you got the job done. So my hat's off 100% to you. And then don't stop. Keep on studying. Look at what's next. And keep it moving. All right, question number 2. And Red Goose is in the lead with almost 1,000 points. I've got some double points coming up for some of these options as well. So here we go. The code to log in is in the bottom right-hand corner if anybody needs that. And here is the next question. It is worth double points. Which layer 2 destination type is used in this ARP reply? And Jay Lincry, there, if it gives you a username in Kahoot, some kind of a fun made-up name, there should be an option to either click on that or continue, which will bring you into the live game. I'm also going to remove an answer off the board here. The red answer, or if there's a colorblind issue, the Anycast is not the correct answer. Rule that one out. The answers are pouring in. Oh, I love it. I love a good competition. If you have not answered already, it is also not, I repeat, not multicast. That leaves two options. And this is an ARP reply. All right, which layer 2 destination address is used in this ARP reply? Let's talk about that just for a few moments to confirm, and then we'll move to the next question. So let's imagine we have two devices. We have, let's say it's a PC, and this thing looks like the hockey puck. We'll call it router 1. And this PC is connected to a switch, and maybe that PC is in VLAN 10 or 20 or whatever. And the router also has an interface in that same VLAN as the PC, and the PC is using 10.1.0.1 as a default gateway. Or maybe it's FHRP, like hot standby routing protocol, and it uses something else. But anyway, the PC says, oh, that's my default gateway, but I don't have its layer 2 address. So the PC, when it needs to reach and use this interface on the router as a default gateway, it's going to use ARP, Address Resolution Protocol. The ARP request, which is not what we're talking about here, but leading up to it, the request is a broadcast. And that's because this PC doesn't know the layer 2 address of this guy, so he sends out a broadcast. Everybody in the VLAN hears it. The person who owns this IP address responds and says, oh, that's me. Oh, and guess what? For that reply, that's what we're looking at right here. Look at the addresses. So anyway, this is a ARP reply, and the ARP reply is a layer 2 unicast. And the reason it's unicast is when this PC does the ARP request has the details for the PC's layer 2 address. And so when R1 gets the request, it says, oh, I now know this PC at .50 and its layer 2 address because it was included in the ARP request. So it just does a response directly to that layer 2 address at layer 2 saying, here is my information. And so this was basically answering the question, what is the address? What is the layer 3 to layer 2 mapping for the default gateway? So long story short, the response, the reply that's coming back with ARP is a layer 2 unicast address, specifically to the address of the client who requested it. All right, 65 of you got that correct. I'll say what I was about to say for another question. Let's move forward. On top, we have Nimble Egret with 2,915 points. Are you having a good time? I am so glad that you are here. Hopefully, every question that you look at with an attitude of, okay, I'm going to use this as an opportunity for learning, for improving, and I'm going to get the job done and get your CCNA. It's a stepping stone, and it's a good one. And I took my stepping stone a long time ago, and I'm still making stepping stones and taking those, and I encourage everybody to do the same. You can do it, and I can help. Double points. Question 3. What is the default OSPF network type for 15.1.1.0 based on this screenshot? So if I was looking at this question, I would first ask myself, which interface is associated with the 15.1.1 network? Which, in my estimation, appears to be gig 0/1, based on the show IP interface brief command. Oh, also based on the show IP OSPF interface brief, which also confirms it's connected to the 15.1.1 network. So the real question is, what is the default OSPF network type for an Ethernet interface, whether it's fast Ethernet or gigabit Ethernet or plain old 10 megabits Ethernet. And it's not any word or any, it's not a type that includes the word point. So you can rule out any answers that have the word point in it. Good luck. Avery, I feel you, man. I answer too quickly a lot of times too. All right, it is a broadcast, OSPF network type of broadcast. I think what I'd like to do is this. Let's take a quick peek at this. I just so happen to have a router here, and we're not afraid to use it. So if we did a show IP OSPF interface brief, now the brief option, it doesn't exist with Packet Tracer, but you can still do a show IP OSPF interface. It would show you all the details, still effective. So if we wanted to enable OS, let's do a show IP interface brief just to make sure I have some interfaces. There we go. So I've got gig01 right there. And if I wanted to enable OSPF everywhere, we could do a router, if I spelled that right, router OSPF process ID 6783. That's my CCIE number. And then enter. And then we could do a router ID command of 1.1.1.1. So by default, OSPF is going to use the router ID that we configured right here first. And if that doesn't exist, it'll use when OSPF is started, it'll use the highest IP address on any loopback interface. And if you have no loopback interfaces, it would then use the highest IP on any physical interface or any other interface other than a loopback for the router ID. All right. So then if we wanted to include network, the 15.1.1, we could do 15.1.1.1, and then we could use wildcard mask of this, 0000. It says anything that starts with 15.1.1.1 is going to be part of OSPF. And if I don't care about the last octet, I could do 255, and that would mean it doesn't matter what the last octet is of the IP address, we're including that interface, and then we tuck it into an area, just like that. So if we do a show IP OSPF interface brief now, it's saying that, oh, wait, why is that? Well, this right now is the router thinking, oh no, I've just enabled OSPF. Maybe there's a designated router on this network or a backup and or a backup designated router because the network type is broadcast by default. So if we do a show IP OSPF interface for gig 0/1, in that output right here, it's showing us that we have a network type of broadcast. It's in this output. Don't make me look for it. Oh, there it is right there. All right. And so in a moment, when it sees there's no other designated router and the timeout has expired. Oh, right here. Yeah. So basically it's almost there. So if we do a show IP OSPF interface brief, now it is the DR. I'm the DR. I'm the designated router because no other routers were present. And by default, Ethernet interfaces are a type of the OSPF network type of broadcast by default. All right. Great job. And 56 of you nailed that. And I bet you that if you got that same type of question again, you'd say to yourself, you know what? I think I understand now that if it's a Ethernet interface, the default network type is broadcast. And you just can't forget that information. The default network type for OSPF for an Ethernet interface of any flavor is broadcast. All right, moving forward. Here we go. Next question, taking the scoreboard on the way. We have Nimble Egret with almost 5,000 points. We've got, wow, Awesome Deer is the highest climber. At the bottom it says up 51 places. Wow, way to go. Awesome Deer. Here's our next question. Question number 4 of 11. Having a great time together as we identify our strengths and weaknesses in CCNA world. What destination types are used in an IP version 4 DHCP discover message? And Jonathan, your question in the queue, let me answer that right after this question timer expires. Thank you for the question. Oh, great. Big clue. The answer to this question ends in cast. And I think this is multiple answers are correct here. So choose all that are correct. Abreu, the link for this live Kahoot is in the bottom right-hand corner. It's kahoot.it if you want to use a web page, or if you can use the app on your like Android or iOS, that works too. And then the PIN code is at the bottom right. So, Obey, regarding questions above and beyond CCNA, today and this channel, and this is focused on CCNA, so you can DM me directly if you like on Discord. I'd be happy to answer it there. We also have a non-CCNA channel on Discord. You can ask it there too. I like the 999 J-Strick saying, I don't know. All right. That's too late. I was going to rule out a couple answers, but it was too late. All right. So, wow. Nailed it. Most of you nailed this. So, a DHCP Discover message, if we take a look at the details here of this, as I bring out my pen, there it is. And let me change my font size just a little bit. All right. So if we have a client, so this is Bob's PC or anybody's PC, and they're a DHCP client, when they first power on, they issue a DHCP Discover message, which basically says, hey, I'm looking for a DHCP server who can answer me. And if there is a DHCP server, the answer would come in as an offer. This would also be true if there was a relay agent, IP helper, which we talked about another time. So the offer comes back. The client says, I would love it. I'll request that address that you're offering. And then the server follows up with an ACK, which is short for DHCP acknowledgement, saying, I know you got it. Great. Thanks for letting me know you want it. So in the Discover, this guy right here, it is always going to be a broadcast. Now, where is it going to be a broadcast? So at layer 2, it is going to be a broadcast. There's a lot of reasons for that. One is that this Bob's client has no clue where a DHCP server would be, so the protocol was written so he just blankets in the entire VLAN a broadcast. And if we looked at the layer 3 header as well, because DHCP runs on top of UDP at layer 4, you need to have something at layer 3, and so at layer 3 it's also a broadcast. So a broadcast in IPv4 would be 255.255.255.255. So that's all bits on for the layer 3 address. That's referred to as the layer 3 broadcast. So it would be 48 bits on in the layer 2 header and 32 bits on in the IP header, represented in hex, usually in dotted decimal down here. All right. Great job. Great job. Great job. Nice work. I love it. Most of you got that absolutely correct. My appreciation goes out to everybody who's here. Nimble Egret is on top of the stack with 8,667 points. Let's take a look at our next question. I think we're close to halfway done, almost halfway. Which of the following is an IPv6 globally routable unicast, playing into our theme, address? 50 seconds left on the clock. And Ryan's asking about loopback router IDs. It's always better to hard code your router IDs, and that way you know what they're going to be in a production environment, not have to guess or wonder. All right, nailed that one. Fantastic. This is the only address. Well, that doesn't help, Keith. That's a picture of some cables. How's that going to help? It isn't. So 2000, a globally routable IPv6 address begins with 2000 through 3FFF. End of story. Everything else on the board is link local addresses or multicast addresses or unique local addresses, and the green is the only correct answer. I had a question earlier asking, If we're using a /30 or a serial link with OSPF, does it assume a point-to-point network type? And the answer is no. With OSPF, if it's Ethernet, the default network type is going to be broadcast. If you have encapsulation at layer 2 that's point-to-point protocol or Cisco's HDLC, like on a serial interface, then the default would be point-to-point. Everything else you've got to play with and tweak. There are some exceptions for frame relay, but nobody likes frame relay anymore. That died like 10 or 12 years ago, so maybe 20 years ago. All right, so thanks for that question in the queue earlier. Nimble Egret still on top. Here's our next question. Hang in there. You guys are doing great. Multiple select, which means there's at least 2 correct answers. What is true about R1's gig 0/1 interface? Belai is asking about my favorite network emulator these days, and although I have used GNS3 for decades, I currently use EVE-NG for my work at the CCIE level and professional level. But for CCNA, the free packet tracer is the absolute hands-down winner. It is free. It responds very, very much like it would if you were in a live environment. There's a few exceptions, but they are minor. And it is free. So packet tracer, and there's one other option I want to share with you about getting hands-on practice, and that is packet tracer. Thanks for the question, Belai. You guys want to hear a joke that Wendell Odom told me a few years ago? It was, "What's a gateway?" And I said, "I don't know. What's a gateway?" He goes, "About 50 pounds, depending on the gate material." Wendell Odom's great. All right. A lot of people are saying that we're joining a multicast group, which is great. So over here, the blue answer is a IP version 4 multicast group, but what it's showing here is IPv6 and an IPv6 address. So blue answer would be out. And then FE80, that's a link local address, not even a multicast address in IPv6. So the only other options here are FF02::1 and FF02::2. One is for the all devices on the network who are running IPv6, and the other one is for all routing IPv6 devices like a Cisco router. So we could actually do a little testing like that to see that in action, because I encourage everybody to verify what they learn and see. So if we did a show IPv6 interface for gig 0/1, I'm not running IPv6 on that interface. Great. So let's go ahead and let's do a IPv6 enable. Maybe we should go to the interface. Interface gig 0/1 and IPv6 enable, and do show IPv6 interface gig 0/1. That's a mouthful. See how I joined that group right there? FF02::1. I have not yet enabled IPv6 unicast routing, and so it's just enabled. IPv6 is enabled, and it joins that multicast group by default as part of Neighbor Discovery Protocol for its functionality. So if we did a config T and IPv6 unicast routing, and then we go to interface gig, you should do show command. I think it's in my cache here. Yeah, show IPv6 interface gig 0/1. Now it's joined the additional group. So previously it had joined just FF02::1. And now that we've enabled routing, it's also joined FF02::2, which are the well-known multicast groups. I shouldn't say well-known, but they are the multicast groups that are joined by a router that's participating with, think about this, Keith. I didn't want to give away another question that's coming up. That's participating as part of IPv6. All right, there are some other questions coming up, and it's going to be related to multicast groups. So I will hang on to those. Let me give you the big picture again. And the scoreboard, we have Nimble Egret refusing to let go of the lead now at 11,425 points. But the reality is that everybody who's participating is a winner. You're awesome. Thanks for being here. Again, if this is our first time meeting, let's get this thing going. Let's get this show on the road. I will not pussyfoot around. I want to push you to get your CCNA. It'll be helpful. So what uses the 1-to-1 of many approach? What the heck? 1-to-1 of many? What do you mean, Keith? Well, let's imagine we have two servers. I'm going to have these two kids act as they're identical twins. And we have two servers on different parts of the planet. There is a way, if they're identical and have the identical content, like they're both DNS servers or whatever, there's a way to route to the closest one, and they could both have the same exact address. But routing-wise, we would be routed to the one that's closest to us geographically or network-wise. So there is a technique listed here on the board that does exactly that. It's big with IPv6. It also works with IPv4. And CSS is saying, I don't know anything about IPv6 yet. No problem. I've got some great stuff on the YouTube channel or whatever you're using for studies. And as soon as you learn about IPv6, you can revisit these questions and have a great time with it. This is Anycast. Anycast is the idea of having the same IP address space and hopefully the same servers in multiple locations. Let me just go ahead and elaborate right here on top of the screen. So let's say this is us, you and me. We're sitting at this computer. We are connected to a cloud. And then there's another cloud. The cloud simply representing like some stuff. And then we have server 1, and over here we have server 2. And let's say both those servers have the address of 8.8.8. And I'm not saying this is exactly how Google does it because it's not identical, but let's imagine we have 8888 advertised by server 1 through a routing protocol and 8888 advertised by a routing protocol over here. Now, let's imagine that we are using 8888 as a DNS server. So we forward our packet to our default gateway, and then it's routed. Now, which DNS server is going to respond? And I would argue it doesn't matter. If they both have the information, I don't care. Just any one of them. And that's how Anycast works. With Anycast, we can have two identical IP addresses or network address spaces. And behind those, we have identical services. And so our service provider is going to route us to whichever one's the closest. So let's imagine that server 2 is the closest. Our packets are routed there, and good to go. And you might ask, well, Keith, how does it make a decision on, which path to take and how do I route? All the fundamentals that we're talking about in CCNA that we've covered and will continue to cover about reading a routing table. How do routes get into the routing table with an IGP? Like administrative distance, and then the longest match, and if there's multiple routes, the best metric, and all that order, that matters. And in the world of BGP, Border Gateway Protocol, it's very similar. There's a pecking order about how routes get in, which routes are going to be believed, and it's really just an extension of that same logic of making sure we know what the routers will do based on a set of situations. And so Anycast is the idea of 1-to-1 of many. In this case, we have two DNS servers, and all we really want to do is to one of them. So it's unicast traffic going to one of those resources. In fact, any one of them, and that's why it's called Anycast. And the same concept holds true for IPv4 and IPv6. So if you didn't know before, you know now. That's how Anycast works. And as far as CCNA is concerned, there is a little bullet, and I'll read it to you. Let me bring up this real quick. Oh, this is thanks to Morgan, too. Morgan Scott on the Discord server. Man, I appreciate everybody helping keep it real. And he said, Keith, what about Anycast? I said, I don't really recall a lot of Anycast in CCNA. He goes, what about section 1.9? Compare IPv6 address types. And 1.9, D as in David, Anycast. I thought, that's making it into the quiz tomorrow. So he told me that, I think it was yesterday, at the office hour, which I have on Discord at 10 a.m., and so I incorporated that as part of the quiz, and that's the quiz question that you just enjoyed, thanks to Morgan. And also, if you didn't like that quiz question, blame Morgan. I also want to give a shout-out to Kelvin, who does an extreme amount of help and assistance on the Discord server. In fact, yesterday, let me get this thing right. There we go. So yesterday, he spent a few minutes with me proofing these questions. And so, Kelvin, thank you for all your service as well, and everybody else who's moderators and helping other people answer questions on the Discord server. I think we're like 4,000, maybe 5,000 people helping each other. So I'm not the only resource there, because I don't think I could do the job of directly communicating with all of you, one-on-one. But there's a lot of great people in that community, so take advantage of it. Let's get it done. And then when you're done with your CCNA, let's refresh those skills, keep them current as you progress, and you can help others in their journey as well. All right, Nimble Egret still on top, 11,425 points. And question 8 of 11. Multiple select, at least 2 correct answers here, double points. Based on the output, what is true? And Converge World is saying, I would love an OG of IT sticker for my laptop. I am working, on a way that I can help get people some, tchotchkes and shirts and stickers and things if they want them. So I'm working on that. And Converge World, I will announce something within the next couple months on exactly how that can be made easy. Thank you for the request. I'm going to take one answer off the table, and that is that EIGRP, it does use a multicast group for its function, but the multicast group that EIGRP uses is not 224005, nor is it 224006. So blue is off the table. All right, router is running OSPF, which indeed it is. In fact, let's do a real quick verification. Now, I want to share with you that as I'm demoing a few of these things, that you can also, as you're studying something with Packet Tracer, especially now, because Packet Tracer doesn't require you to re-authenticate every single time. With multi-factor authentication, you could authenticate, say, I want to remember this, remember me for a few months or weeks or whatever it is, and you can just launch it, bring it up on your device, and away you go. So when you have questions or studying something, just lab it up. Do a few show commands based on what are being shown in whatever study material you are using. So if we did a show IP OSPF interface, I'm going to say brief just because that gig01, we enabled that just like a few moments ago or a few minutes ago on this device. It is currently a DR, the designated router. So if we did a show IP interface for gig 0/1, it would show us that it has joined 2 multicast groups. And that is because 224005 is the OSPF multicast group that is used by all OSPF speaking routers. And 224006 is a special multicast group that is joined by only 2 devices. That is a designated router and the backup to that, which is a backup designated router. So if we were to do this, no router OSPF 1, oh no, I called it 6783, I think. I'm going to verify that real quick. Show IP protocols. I just want to verify OSPF is not running. Great. And then we'll do a show IP interface gig 0/1. Look at this. See how it used to have joined those multicast groups? Not anymore. That's because OSPF isn't running, so it gave up its responsibilities. All right. Good work on red. That was the absolute correct answer. And not only was... so R1 was a DR. Yep. All right. Let's click on next. And we've got just a few more. Balanced Camel has taken the lead. followed by Creative Hair, Nimble Egret, Bronze Emu, and Majestic Yak. Okay, here is question number 9, rounding the corner. Double 2x points. What is this? That's what that IP address would make if it made a sound. I've also given you 120 seconds on the clock, so take your time on this. Do not jump to a conclusion. Oh, Loom, I am loving your comment. Loom is saying the block size is 4, ... That's exactly, that's a perfect approach to doing this. All right, I'm going to pull off one answer from the board. It is not unicast address. Yellow, the bottom left-hand corner on the screen, is not the correct answer. I know, Harold, you can't change the answer. It's like, oh. The great news is that you can practice here, study now, get ready now, and then when you go take the exam with it's just you and the digital proctor, you can just crush it. And you don't have to crush it. I got a comment the other day saying, oh, I didn't get the best possible score I could have on CCNA, but I did pass. I'm like, dude or dudette, it's amazing. You passed. That's the goal. It's just to pass and get that knowledge. All right. Okay. Well, 29 people think it's a broadcast address. I'm going to go with Loom's comment and idea because I think it's a winner. And I'd like to share that with you. Let me clear that off. So if you've joined me for Subnet Saturdays, which is like 11 or 12 videos, there's a playlist just for it. It's called Subnet Saturdays. You can be an IP subnetting ninja or really proficient person, whatever category you want to put that in regarding subnetting. So with 252, that's decimal, and that is for the last octet. So I'll put 4th octet here. And for the 128, 64, 32, 16, 8, 4, 2, and 1. If you think, what is that, Keith? Come join me for Subnet Saturday. I'll walk you through the entire details. And 252 says this bit in the mask is on, and these 2 bits are off. And so the block size is 4. And that means we can just really ignore the first 3 numbers. And for that last 4th octet, the subnets are going to be 0, and then add the block size 4 and 8, 12, 16, and so forth for that last octet. Now, this is a speed reading version of it for those of you who already gone through the Subnet Saturdays. If you haven't gone through Subnet Saturdays yet and you want to learn IP subnetting and really be good at it, do it. Join me, and then join me if you have questions in the office hour, and you can rock. I've had so many people tell me, oh my gosh, you're my last hope, like Obi-Wan Kenobi. That's not. What I did for the Subnet Saturdays is I learned subnetting back in the 90s. No, my first IT job was like in 87. So anyway, maybe the late 80s, early 90s, and I thought it's really hard. Like 2 to the power of 0 is 1. It's like, I'm not a PhD in math. Why? I don't. Anyway, long story short, I created a method that I would have liked to learn IP subnetting. It's simple. You don't need to do math. Like, you have to do basic addition, but I think that almost everybody has that down, and you can do it. So it's a course built just for you. So take advantage of that. So the block size is 4. Here's our subnets, and that means the range here would be 1 through 2, and the broadcast would be 3. I'll put B here. For the 4 subnet, the range would be 5 through 6, and the broadcast would be 7. And if we go here, this would be 9 through 10 with a broadcast of 11. And this would be, we can stop right there because guess what? Wonk. That's a broadcast address. So this address, blah, 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 first 3 octets, .11 with a 30-bit mask is a broadcast address. So that's why green is correct. All right. I appreciate everybody who participated in that. That was a little more tough of a question, but it verifies you could answer. That type of question really helps confirm that you understand how that works. And so thank you. If it was, yeah, it could have been a host address if it wasn't the broadcast for that subnet. Otherwise, host address would be great. Okay, question. I think we're on one last question. 2 more to go. All right, so Balanced Camel is on top. Everybody, thank you so much for joining me today. We got a couple more questions, and then I will stick around just for a few moments here, and then we'll jump into Discord if you want to see me there too. What does an ARP request use? Good luck, everyone. All right, layer 3 of anything is not the correct answer. All right, most of you nailed it. That's fantastic. Super pleased about that. So let's take a look at this ARP request. ARP is an interesting one, and I'll tell you why. So here's the layer 2 header, the Ethernet header with source and destination. And that destination would definitely be a broadcast. Because it's a request, we don't know what the layer 2 address is of the device on the local network has an IP address, so that's a broadcast. And then the payload, and Kelvin pointed this out yesterday, in the layer 2 header, it's going to point out the next protocol in the protocol stack. So if it was IP version 4, the next protocol would be 800. For ARP, in the layer 2 header, it's pointing to the next protocol of 806. And yesterday, when I asked Kelvin, I said, okay, so what is that protocol number for ICE for an ARP request? He told me. I was like, oh, man, all that information just at ready demand, just on instant recall. So Kelvin, thank you for that. Anyway, so the next protocol up is address resolution protocol. So anyway, in this ARP payload here, there's no layer 3 IP header inside of an ARP request. The ARP request and the ARP reply, it has data and information about the mappings, but as far as the actual protocol stack is concerned, there's no IP header. So it doesn't include an IP layer 3 source or destination, nor does it include a layer 3 broadcast or unicast or anything else address in the protocol stack because it doesn't have it. It has the data, but it doesn't actually have that part in the protocol stack. I'm very pleased that so many people got that so right. Fantastic. All right, I think we have like one last question. Okay, if this is your time, let's do this thing. Now, when I refer to this being your time, it's maybe your time just to make a commitment to studying and a commitment to setting a date for your exam or a commitment to getting a little bit better or allocating time. So whatever this is your time means to you, I am 100% here to help you do exactly that. Let's progress together. Let's move ourselves just one step forward. You can do this. And I know that I can help you do this if you'll just let me. If you'll put in the time and the effort, I will put in the help on the back end to help reinforce those concepts and to steer you correct if you got a bad angle on something at some point. All right. So here we go. Last question. Question 11 of 11. It is double points. Which OSPF network type is used between R1 and its neighbor? Won't you please, won't you be my neighbor? Kelvin Tran, thanks for that comment. You're so great. Okay, I'm excited about this because we did, I don't know if I touched on it, but nailed it. 77 of you say point to point, and that is correct. And it's based on the layer 2 encapsulation. So with a serial interface on a Cisco router, which we don't see a lot anymore, but CCNA would like you to know this. So if you have a serial interface, like serial interface 0/1/0 or whatever it is, the default encapsulation is going to be HDLC, which is Cisco's HDLC, and not uber compatible with the rest of the world's HDLC, but that's a separate discussion. And if we configure PPP on it, then we can be more compatible with third-party vendors. However, in either case, whether it's HDLC by default or PPP that we've configured on it, the default OSPF network type is going to be point-to-point. So Ethernet's going to always be broadcast, and serial links by default are going to be point-to-point. And we can change those if we want to, configuration-wise, but those are the defaults. All right, and Michael's saying, yeah, you did touch on it, but man, you guys all nailed it. I'm so happy about that. All right, let's go ahead and look at the podium. This will be fun. Let me have it play the music for us. All right, Balance Camel, way to go, way to go. And if I could, let me go ahead, and these are the toughest questions that were asked. If you look at the upper left-hand corner, it also shows up here the percent correct. This is regarding, so 36% of all the questions were answered correctly. And this is perfect. It's the right time to find out. And so if you're just at the beginning of your journey, like I had comments that said, I haven't studied IPv6 yet. No worries. Take it all in stride. This entire playlist of all the quizzes is available on my YouTube channel. So it's in a playlist called Quiz Questions, and that way you just go down, scrub them when you're ready, and all different topics. All right, also I'd love to get some feedback from you if you are logged on to the Kahoot app, either through a browser or through the app itself. Go ahead and let me know your feedback. That's helpful for me as a trainer and for this channel, so I can help. Also, I am working on, over the next month or two, I'm going to be working on some options to get more swag available for like the, I think my mom wants one, a few people who want that stuff. I'm going to set up some methods that'll make it very easy to get that stuff. So, I think that's mostly it. Let me go ahead and bring up the camera here. Let me move a couple things around. And let me see if there's any last questions that I can just grab that were outstanding. I think I answered most of them as they came in. Okay, so as a heads up, next Sunday, 11 o'clock Pacific time, adjust your calendars wherever you are in the world. Let me know, or actually, if you would, let me know what country or what geographic location you are currently watching this from, because that'll be helpful for me as well. I loved seeing that. Last week, it was just like all over the planet. So if you could share that with me, that'd be fantastic. Also, next Sunday, 11 o'clock, I'll have a brand new quiz for you. It'll be like our 25th week in a row. I'm loving it. Also, 10 o'clock a.m. Pacific time on Saturday is our office hour. So you can show up, bring your questions. My goal there is bring your questions about what you're studying. So I can tell you what not to do, but my intention, what I want you to do is if you're studying something, maybe it's leaf spine architecture, or you're studying OSPF, or you're studying routing cables, or administrative distance, or why does spanning tree behave this way and not that way, or LSA types, if that's what you're into in OSPF, or automation, if you have specific questions there, or QoS, or NAT, or NTP, or authentication. If it's on the blueprint and you're studying it and you have a question specifically about it, bring it. And it's pretty much first come, first serve, but it's an hour from 10 to 11 every Saturday. and right on the Discord server. And there's the links for the invite. So join the Discord server. If you want to DM me there, you can. I usually check that 2 or 3 times a week, so it may not have an immediate answer if you have a question. A lot of times people have done this. This is cool. They'll work on a packet tracer lab, and in the packet tracer lab, they'll get stuck on something, and they'll say, oh, this isn't working for me. I know it's one of the packet tracer labs I created, and I've got like 30 plus available online for free. And they'll say, it's stuck here, save it, send it to me on Discord in a direct message DM, and then ask me to look at it. And tell me what the challenges you're facing. I'll open it up. So those packet tracer labs, if I created like 2 or 3 months ago, because I created so many, I don't always remember the top of my head what's wrong. So what I do is I open it up and I just do a little troubleshooting, like, okay, what's wrong? And I check the basics. And I oftentimes have calls too. So I've DM'd, I probably had 3, I had 3 calls this week with individuals where I thought this is going to be better explained if I can just have a quick call. And we can do it all through Discord. So it's so simple. Just no video, just, audio. And then I can share my screen and I can walk through something and say, what about this? And how about that? Did you check this? It's fantastic. So I want to put my, one of the few things I have, well, everybody has very limited time, right? And so one of the things I want to offer to you is a little bit of my time consistently so that if you have a question, I can be there to help. All right. So let's do this. Oh, great. So great question. Tim's asking, well, greetings from Belgium. Welcome, Belgium. Glad you're in here. He's asking, based on the output, what is true about, what would the OSPF output of the router look like if it was not a DR or BDR? It just wouldn't join those multicast groups. So if you do a show IP interface for gig 0/1, and by default it says the multicast groups join for IPv4, which was 224.0.0.4 and 224.0.0.6, that was because it was OSPF router, that's the .5, and it was a DR, that's the .6. So if we did a no router OSPF, which I actually took off, it wouldn't have joined either of those groups. And you know what? The same thing happens with IPv6. So if we did a show IPv6 interface for gig 0/1 and it was running OSPF and it was a DR, it would be FF02, that's the multicast address space for IPv6, followed by a 5 or a 6. So : 5 and : 6. They use the same last numbers as IPv4.